here are the homework answers. On yesterday's homework answers, there was one mistake. We changed the worksheet, but we didn't change all the answers. So it wasn't really like we solved it wrong. It was just the very last one had the answer to an old problem. So let me tell you what that one was, because I want to make sure that you're not confused by it. So this is last night's homework. But on the triangle sum theorem homework, number 17, there's a correction. Number 17, the answer was 18, 72, 90. That was number 17 on last night's homework. There was a mistake in the, that's a weird I, sorry. There was a mistake in the answers typed up, okay? So you were probably wondering about that, and there you go. Last night's homework, number 17, was 18, 72, 90. What about tonight's homework? Which ones would you like me to go over? Quan, you want me to go over 17 from last night? Okay, I'll do that one. What else? So we're going to begin with number 13. I think on number 13 is when we're using our new rule. Come on, Word document. There we go. If you can tell, my computer is having a few issues lately. I bet there's an easier way to solve this one, and like I said, I'm going to teach you a really easy trick to use on Friday, tomorrow, that will help this one. So once I teach how to solve this one, then after Friday, erase that from your memory because you're going to have a better way on Friday, okay? But for now, with you and your homework last night, how would you have solved this one? Well, first, I would rewrite this angle right here. I would call that angle 180 minus its linear pair. Is that okay with everyone to start with? That angle is 180 minus 3x minus 5 because those are a linear pair. Now, we know from the exterior angle theorem, we know that this angle plus this angle equals that angle. So we know 2x plus 25 is the sum of the remote interior angles. 100 plus 180, and I'm going to distribute that negative, minus 3x plus 5. Do you see how I distributed the negative? Okay, so now we've got 2x plus 25 equals 280. Let's do 285 because you see that plus 5. Let's combine like terms. 285 minus 3x. 5x equals 260. And then divide 260 by 5. 52. Oh, good. So the thing about this problem was that we have two exterior angles and one interior angle. And you can't use that new theorem with two exterior and one interior. So you had to make one of the exteriors into an interior. Number 19, the measures of the angles of a triangle are x, x, and 3x. If the measure of the largest angle is increased by 10, the measure of the largest angle, which is 3x, is increased by 10, and the triangle remains isosceles, how would you represent the angles in the new triangle? So, okay, so 3x plus 10, that's your new largest angle. Now, if you're going to add 10 to one angle, and you want to remain isosceles, then you're going to have to compensate for that, and you're going to have to undo it in your other angles. So the other two angles were x and x. If I added 10, I need to compensate for that. And what I mean by that is I need to take away 5 and take away 5. Now, I haven't really done anything, right? I added 10, but I took away 5 and I took away 5. So I've maintained the ratio that I wanted to have for my angles. So that's how you do number 19. Number 20 is similar, but this one's with multiplication. So this one's a little bit tougher. This is a very K-level problem. This is deeper thinking. So So the measures of a triangle are x, x, and 4/3 x. What I want to do first is I want you to add those angles up. What do you get? What is x, x plus 4/3 x? So that's like saying 3/3 x plus 3/3 x plus 4/3 x, right? If you get a common denominator. So 3 plus 3 plus 4. So if you add those together, you get 10/3 x. We need to maintain that sum when we do things to our angles. The largest angle is doubled. The largest angle is doubled. So 4/3 times 2. The largest angle is now 8/3. The largest angle is now 8/3. Now, I still want my angles to add up to 10/3 because I need to remain isosceles again. So remember, if I do something to one angle, I have to undo it to the other two angles. So if my angle is still isosceles, it still has to equal 10/3. What can I add to 8? Well, 1/3 and 1/3. You see how that works? 8 plus 1 is 10, and two of my angles are congruent. That's how it remains isosceles. I hope that that made sense. It was a difficult problem. Let's do number 17 from yesterday, and then we will move on to today's lesson. One of you said, I don't get the ratio problems. Well, let me help you. I'm going to help you get the ratio problems. You're going to be like, oh, that was so easy. On this one, oh, sorry, this one actually is not a ratio problem. This is number 17 from yesterday. It says, in a right triangle, so you stop right there, and you draw yourself a right triangle. In a right triangle, the measure of one acute angle is 4 times the measure of the other. So you call that one x, and you call that one 1x. Call it x and call it 4x, excuse me. That's like them saying the ratio of the acute angles is 1 to 4. When you see a ratio problem, you need to attach a variable to those ratios. 1x, 4x. Does that make sense? This just became a very easy problem. X plus 4x plus 90 equals 180. Or maybe you already knew that the two acute angles of a right triangle always add up to 90, so you can just add those two to equal 90. Okay? Oh, you thought I was really angry? Okay. So that's that one. Today's lesson is called Triangle Inequalities. So if you're taking notes, you would label it Triangle Inequalities. You're going to like this lesson. It's an easy lesson, it's a fun lesson, and it's really applicable. Okay, so you're a landscape architect. That means someone who designs outdoor spaces, and you're designing a deck. You want to place the lounge chairs. I know, big decisions here. You want to place the lounge chairs in the two biggest corners, in the two largest angles. Where should the lounge chairs go? Pretend that you don't have a life-size protractor. You can't walk up to those angles and measure them to find out which ones are the largest. So which ones are the largest if all you have are the sides? Because you do know how long the sides are because you designed this deck. So this is what our lesson is all about today. It's kind of fun. No, Lars, we're not doing trig yet. Stop asking. So I don't really care what the angles are. We are not going to find the angles. We're just going to find out how to order them from smallest to largest, okay? So which two are the largest corners? No, we don't have a life-size protractor, Rishi. Yes, you could put even a tiny one in the corner, but we're not going to do that. We don't have a protractor with us. I don't think landscape architects carry protractors around. So anyways, we're about to learn the answer to this question, but I agree with one of you. I would agree. I would put it in this corner, and I would put it in this corner, and we will find out why in a minute. If you put your hands together like this, put your hands together like this, like you're praying, I guess. As you open your hands, as the angle gets bigger, what happens to the distance between your fingertips? The distance gets larger as the angle gets bigger, right? As the angle gets smaller, what happens to the distance between your fingertips? The angle gets smaller, the distance between your fingertips gets smaller. It's a direct relationship, right? So if your side is larger, then that angle opening up to that side must be larger. And if this side is larger, one of the larger ones, then the angle that opens up to that side must be larger. So the larger the angle, the larger the side across from it. The smaller the angle, the smaller the side across from it. So here we go. Here is the meat of half of the lesson. In a triangle, the largest angle is always across from the longest side. Largest angle is always across from the longest side. The medium angle is always across from the medium side. And the smallest angle is always across from the shortest side. Common sense, right? Yeah, common sense. Okay, this is nice. This is easy. This is so different from writing equations of lines, right? It's like, ooh, we're back in geometry now. I love it. I'm going to give you a second to write it and we're going to move on. So, drag the name of the side to the correct spot on the triangle. I want to know the shortest side, the medium side, and the longest side. Would someone like to request control and drag those to the correct side? Oh, Graham was first. Sorry, Graham won. Man, you were quick. Now you have to solve the problem. So Graham's saying that the one across from 66 is the longest, the one across from 58 is the medium, and the one across from, ooh, what was that missing angle? What did y'all get for that missing angle? 56. So you did have to find the missing angle. That was the first step. Very good job, Graham. So this is the smallest. So smallest goes with shortest. This is the, this is the medium. So medium goes with medium, and that is the largest angle. Largest goes with longest. Very good. All right, new part of the lesson. Here are some drawbridges over the Chicago River in Chicago, Illinois. My husband's actually working on a building in Chicago. He goes there all the time. So anyways, when the ships pass through that are too tall, right, they have to open the drawbridge and they close it again. What needs to be true about the lengths of the drawbridge so that the bridge will span the river when the bridges go down? What needs to be true about the length of this compared to the distance between the base of the bridges? What needs to be true? So if I call this A, and this B, and this C, what would need to be true? Right. A plus B would need to equal C. Now, what if A plus B, what if it was greater than C? What would happen? Y'all can use your mics. When it tried to come down, what would happen? Crash. That's what it would happen, Chloe. Yeah. Can you just picture the sound happening? Yeah, we would not, that would be bad. Now what if A plus B is less than C? Then we might have something out of a movie. You know when the car like jumps the gap in the movie? Have you ever seen Speed? Anyways, we would probably have something out of the movies. Now, if it was this big of a gap, it might not be a big deal, but if it was this big of a gap, then we'd have some stuck cars, wouldn't we? We'd have some car crashes. People, yeah. We'd have a movie set is what we'd have, Indiana Jones or something. All right, so that leads into our triangle inequality theorem. Now, take a look at this triangle. This is a triangle. We know that 7 plus 8 is 15. 15 is greater than 10, right? And that makes a triangle. Take a look at this one. 6 plus 7 is 13. 13 is still greater than 10, but what's happening to my triangle? It's getting shorter, it's getting flatter, it's getting squattier. Okay, it's getting more obtuse, right? Okay, what about this one? 5.5 plus 6.5 What is that, 12? We're still greater than 10, but what is happening? Are you looking at this? Yeah, shorter and shorter and shorter. 5 plus 6 is 11. 11 is still bigger than 10. Is that still a triangle? Is that a triangle? It's a very obtuse triangle, but yes, it's a triangle. Uh-oh. 4.5 plus 5.5 is 10. 10 is equal to 10. Is that a triangle? Is that a triangle? You should be saying no. It is a line. It's a segment. Yeah. So when two of the sides of a triangle add up to equal the third side, well then it's not a triangle, right? And what would happen if we went even lower? Oh, I don't have the lower one. I thought I did. If we went even lower, if this was 10, and this was 4, and this was 5, then, oh my goodness, it also would not even make a triangle at all. So what's our conclusion about the sides of a triangle? What would our conclusion be? In order to make a triangle, blank. Fill in the blank. Two sides have to be greater than or equal to the largest side. Okay? So here's the theorem. Here is the theorem. Write it down. The Triangle Inequality Theorem. When you add two sides of a triangle together, the sum will be greater, in all caps, greater than the third side. Pick any two sides. When you add two sides of a triangle together, the sum will be greater than the third side. A plus B is greater than C. B plus C is greater than A, and C plus A is greater than B. Any two sides, add them together, will be greater than the third. Okay. Is that enough time? I don't know how many people are writing this down. Can you form a triangle with the following lengths? I'm going to call on people, so please don't type the answer in. Go ahead and write down your answer in your notes, and I will call on people. It's a yes or no question. Can you form a triangle? Yes or no question. No. Johan, it's not multiple choice. On A, you need to put yes or no. On B, you put yes or no. On C, you put yes or no. But I'm going to call on people. Let's do A together so that we make sure we understand what's going on. Can you form a triangle with these lengths? Now, the long way to do this would be you add 3 plus 8, and you say, is that greater than 7? And then you add 8 plus 7, and you say, is that greater than 3? And then you add 3 plus 7, and you say, is that greater than 8? But heavens, we probably don't need to go through all 3 of those steps every time, right? What would be the most efficient way to test if those form a triangle? Look at the smallest. Good, Victor. So you're going to find the two smallest, and you're going to make sure their sum is bigger than the largest. So I always circle the largest. I go through every time, and I circle the largest, and I circle the largest, and I circle the largest. Okay? Is 3 plus 7 greater than 8? It's a yes or no question. Is it greater or is it not? If the answer is yes, then you can form a triangle. Karthik, what do you get for B? Yes or no? What is 3 plus 6? 9. Is 9 greater than 10? It's a yes or no question. Is 9 greater than 10? No, it surely is not. So you could not form a triangle. Okay, now y'all are going to get confused. So what I do, I even do this in my head sometimes. What I do is I picture my largest side as the base, and then I picture the other two sides, and I ask, could they reach, could they reach, could they reach? 3 and 6. Could it reach, could it reach, could it reach? And when you visualize it, there's no way you would ever say yes. You know that 3 can't reach 6 if it's trying to span across 10. So I hope that helps you visualize it. Alton, what'd you get for C? Yes or no? Will it form a triangle or not form a triangle? No. Very good. 2 plus 7 is 9. 9 equals 9. It can't be equal to. It has to be greater. Greater, 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 greater. Rishi, what about D? Yes, very good. 2a plus 2a is 4a. 4a is greater than 3a. So that's yes. Good? Two sides of a triangle have lengths 8 centimeters and 10 centimeters. What are the possible lengths for the third side? All right, two sides of a triangle have lengths 8 and 10. We're not going to discover this because we're out of time. I'm just going to show you how to work this problem. I'm going to call the third side x. We're going to have a max and a min for x. The very largest it could be would be 10 plus 8. That is the very largest it could be. That's its max. So you add them together and you get the max. Then you subtract them, and that would be your minimum. So this represents me adding the two numbers together, and this represents me subtracting the two numbers together. So the third side is going to be greater than 2 and less than 18. Am I going to put a little equal to underneath? No, because it can't be equal. We already discovered that. That wouldn't make a triangle. It would collapse upon itself. So to find the max, you add, and to find the min, you subtract. It's not like domain and range. It's not algebra. I know, I saw you typing that. Find the longest side of ABC if... Draw a picture, draw a picture, draw a picture. Find the longest side if A is 70, B is 2x minus 10, and C is 3x plus 20. So the first thing we would do here is find x. So we're going to add those together to equal 180. Let's see, 5x plus 80 equals 180. I just added them together and combined like terms. 5x equals 100, x equals 20. So now I'm going to plug it back in. 2 times 20 is 40. 40 minus 10 is 30. 3 times 20 is 60. 60 plus 20 is, okay. So now I know all of my angles. I know that the longest side is across from the largest angle. So all I have to do is find the largest angle and draw an arrow away, and I'm pointing to my longest side. My longest side is capital A, capital B with a segment on top. Make sure that you use correct notation when you're answering questions like this. Very good. Good job, guys. Given triangle HAL, let's do triangle HAL, H-A-L. AH is greater than AL, so I'll just put some numbers. AH is greater than AL. I just made those numbers up. I just made up a number that was greater than the other. AL is greater than HL, so let's get smaller. List the angles from smallest to largest. So the smallest angle is going to be across from the smallest side. So I would list angle A, comma, medium angle, that would be the medium angle across from the medium side, angle H, and then finally the largest side means that's the largest angle, so angle L. Angle H, comma, angle A, comma, angle H, comma, angle L. Make sure you put your angle symbols. Once again, we're going to be using correct notation here. Good job. Last problem of the day. Arrange the letters' values from least to greatest. Ooh, there's two triangles here, and you're going to have one on your homework that has two triangles as well. What I would do first is find any angle that's missing. So let's use our triangle angle sum theorem to find the missing angles. Find the missing angle and find the missing angle. Good? Good? Now what you need to do is look at one triangle at a time. You cannot compare an angle from one triangle to an angle from another triangle. So you can never look at more than one triangle at once. You look at one triangle at a time. We're doing least to greatest. So I'm going to start with this triangle right here. Only that triangle. I'm going to order those letters from least to greatest. Well, here's my smallest angle. So A is my smallest side. Here's my medium angle. So E is my medium side. and G is my largest angle. So G is across from my largest angle, so it's my largest side. Now I'm going to look at the red triangle, and I'm going to start all over. The smallest side is across from the smallest angle. 22 is the smallest. Across from 22 is G, and then we would have S, and then we would have L. Notice, on one triangle, I ended with G, and on the other triangle, I started with G. If that wouldn't have happened, I would not have been able to solve this problem. I had to have left off on G and started with G for this problem to work, because you can't ever compare angles to another triangle. Like I said at the beginning, you have to do one triangle at a time. So my final answer would be A, E, G, S, L. Oh, it almost spells eagles, but they're all out of order. That's our sci-falls were eagles. Okay. Anyways, this had to happen, or else I would say can't solve this problem. That is the end of the lesson. Y'all have a great afternoon.